Hello, everyone, and welcome to the fourth Func Prog Sweden meetup. This time we're live streaming with a small audience and live to you. The first one we had was actually live. Second and third we had was like on Zoom, and now the fourth is live streaming. So we're trying out this, and let's see where it leads us. Yes, the agenda for today then is. Oops, sorry. Yep. So we have a short intro, that's me. And then we'll have the first presentation by Henrik Feldt, Patterns of Functional Programming. And then we have a second presentation, C++ for Functional Programmers, by Harald. And then I'll do a short summary in the end. Yes, so why did I start this meetup group? Well, because we love functional programming. We are open and inclusive. We like people to be part of the community and to learn functional programming. We like to share, so this is also why I started this community, to share like how do you get started with functional programming, or how do you develop advanced stuff with not functional programming languages like C++. Yeah, so let's have fun and share and spread functional programming. And this time around, we have a venue sponsor from Funnel. So I'd like to say thank you very much, Funnel, for having us in your office and sharing your office space. And I would like to introduce Ville, who will say a few words about Funnel.
Thank you, Magnus. Funnel is to data like sanitizer is to your hands, makes it clean and ready for use. Please check out our product and ourselves at funnel.io or jobs.funnel.io. You can find us. We love functional programming, of course, I do. I'm part of the CTO team at Funnel and very much happy to have the meetup here with us.
Thank you very much, Ville. Yes, then if you want to be your speaker or sponsor at Meetup, just ping me. You can find me at Meetup. You can find me on most social platforms. If you have a venue and you want to share that for a Meetup, again, please ping. We are always looking for venues where we could maybe try out live streaming in your office. So just contact me or the other organizers, Matthias or Tien. And a short how-to for today then, because we are live streaming this event. So it's the first time we live stream, so we have zero clue how to do this. So we're starting up. Questions in the room, please, presenter, repeat the question so everyone on the live stream knows what the question is. And if you have a question on the live stream, please ask them through the chat in YouTube, and I will read them up as we go along. Yes, so let's start the fun stuff. First presentation is by Henrik Feldt, Patterns of Functional Programming. Thank you very much, Henrik. And now we'll switch computers for a while. Yeah.
I got some reverb going on here. It's a bit of a party trick. Just go close to that one and see if it doesn't like me. Maybe we can turn this down a bit. So welcome. It's still loading here. I think it's the screens that are loading. So I'm presenting on design patterns in functional programming. And the sub-theme here is it's not about monads. First of all, me. Right now I'm working on this new product called Behavioral Analytics with Logger Analytics. Behavioral Analytics, basically the business idea I'm trying to create is to model user segments and user behaviors using causative analytics, and then highlighting both what you can do more of and what you can do less of in order to improve your key metrics. So Logger Analytics is actually initially a software product written in F# for logging in functional programming languages. So a few of the examples tonight will be about this library. Now, the product I'm building is actually a separate application, but this is still free and open source. I have some background in building software. I built some functional web servers. You see the Expecto library out there. I help people with cloud migrations and so on. But back to what's a design pattern and what we're going to speak about tonight. I'd say it's a construction that repeats itself because it's useful and it fits the situation. And also, you could divide them into these, especially when you write functional programming. Parsers and validations, state and handling of state or state mutation, control flow, and this is actually what Haskell is so good at. And then you also got the sync await in Python with Twisted and C# and in TypeScript and JavaScript. And then you got higher order functions, which is very often mentioned. And the other thing that's mentioned, of course, is monads, but I'm not going to go into those. Let's say that monads are nice for control flow when you want to write imperatively. But most of the time you are already writing in an imperative language. So you may not need them. So I was thinking of some interesting patterns that you could use. And I thought of these. You have the delegator pattern, for example. Of course, when you look at design patterns, you have the original Gang of Four book. But it's very old now and is very much geared towards object orientation. In functional programming, you often have this hole in the middle, which we'll dive deeper into. There is one called state machine. So state machine in object-oriented programming is modeled using a lot of classes. But in functional programming, you can actually do it quite nicely with mutual recursive functions. I'm going to show an example of that. Then you have currying. This is like the workhorse of any functional program, because you curry all the time. You curry basically everything that you inject into your app as configuration. And it's also very much used for memory management. Then you have dynamic configuration via a closure and alternatively via a construct. And 3, I'm not going to go through: continuation passing style, scans, reductions, and so on, which is part of the higher order functions. And then different sorts of observables, jobs, promises, tasks, you name it. So let's start with this one, hole in the middle. And I must encourage you on YouTube to just ask questions, and also the audience, you may have to seed some questions here. So I'm counting on you. Hole in the middle here is when you want to reuse a complex function implementation. So let's look at an example. Let's pretend colorize is a very complex function. In this case, it's moderately complex, but you can easily imagine setting up many different things in something that fetches data from an API, such as API tokens, maybe permission handling, looking up what roles you want to send, maybe computing the different query strings you want to attach, and so on. All of these things is something you probably want to do in at least not too many locations inside of your application. And that's why then you can use hole in the middle. What it gives you, the first arrow up here, is something you can pass in, a callback, which then configures the complex thing. What it configures has already been configured to some extent by this complex function. In this case, the complex function is the async that you see on the second bit with the second arrow. And we're calling our config callback to be able to inject more headers or inject more things. So you can say that use this pattern when you have an implementation that's sufficiently advanced and you don't want to leak that complexity into the surrounding system. So then the way you can use this is by having a call to colorize, and then you pass in the local, the contextual data, which you can't otherwise access inside of your complex function. So for example, if the user has typed something in, like 0, 1, 2, 3, etc., local to page, then that's not something that your complex function will know about. So you want to reconfigure it where you call it. And that's when this is neat. The astute listener might have noticed that we're also using currying as part of this example. And this is different because the previous was when you wanted to reuse a complex implementation. Currying is when you want to reuse a complex setup. So back to the same example here, you can see that colorize actually returns a function that takes an item and returns a promise of colorized item. So its first parameter here, and this is TypeScript by the way, is configure. So configure, once inserted into colorize, gives you back another function that you can pass around, a function which is now pre-configured, so to speak. It's configured with a configure callback. And just between these two lines, between the two red lines, you can do arbitrary computation. You can think of currying like when you pass the first couple of arguments, your configuration, maybe your context object, you can do arbitrary lookups, arbitrary calls to web servers. You can pre-compute a cache. You can pre-compute computations that yield results. And then you return some function which uses all of the things that you've already pieced together. So you can see them as a way of constructing or constructors. And in this example, then getColor is the end result function, which we can then use to get color via this API call. So you can say that part of the cost is taken when you execute this. But when you later call getColor, then you don't have to pay the upfront cost anymore of pre-computing the way the function should behave. So that's when you want to use it. So let's move into more advanced territory. We got something called dynamic reconfiguration. In a distributed system, this could be, for example, if you have a set of Kafka brokers and you want to dynamically reconfigure what brokers you send to based on their uptime or based on their liveness. Are they responding to my calls or not, basically? But because you write functional programming, it's not necessarily easy to change things on the fly because everything is basically meshed together into this continuously executing function body that keeps on executing. So you want somehow to inject non-determinism, somehow to inject configuration in there, right? So in this case, it's F#, and I'm taking an example from Loggery, the logging library that I'm now building an app for. And you can see the default configuration on line 19, which sets up, well, what it says, default configuration. And then I'm using this abstraction called dvar for dynamic variable. This is different from the Haskell dvar for concurrency. This is just basically an Excel shell, an Excel cell, which you can then compose together with other cells. And then at some point, you want to use your composed value in a context. So this would be the instantiation. And you can see, for example, dvar create at the bottom bit, where you take in the default config as a value. And you can see the default config is actually a static, non-changing value. But dvar makes it mutable, so to speak. In classical object-oriented procedural, rather, languages, you quite often have that you have global variables, but those variables depend on each other arbitrarily. So at any point when you have more than one or more than two, you have to keep that in mind when you update them and recompute all of the dependents as you go. With this, you don't have to. I'll get back to the implementation. So this is a flyweight. So in the logging library, you want to be able to get loggers from when your app starts. But by then, I haven't configured like the sending and the exporters and targets and the pipeline and everything that you have in a logging framework. So I'm just giving back a flyweight. A flyweight is the design pattern as well, something from the Gang of Four, in fact. And you can see here with F#, you can mix and match object-oriented programming with functional programming. So on the second line, you can see that I take the configuration dvar and I map it so that in the callback, I'm gonna actually break the rule here and move towards. You can see here that you get the config value, the actual current value, which you can then invoke functions on. And that means that you can compute with the most recent value. So now you have an expression, logger d, which is a function expression of, no, sorry, it's not a function expression, it's just a dvar of logger. So that logger will now always be up to date with regards to your configuration. So when the configuration changes, this one changes. And that means you have your suppleness. If you remember the DDD book, it's like a leather jacket. You want it to be supple in the right bits. And this is to be supple in the right bits because now I only have to care about whether I have the right type of a dynamic variable. And if I have that, I can be absolutely certain that dynamic variable is the very latest value up to date. And then in log with ACK, I'm getting the value from this dvar and using it. So the implementation can look like this. It has some mutable cell, something you can update. And when you update the cell in the put down there, you want to atomically switch it out. So this is very similar to Clojure's atoms. Correct me if I'm wrong.
Do you mean that you partially applied the function with a dynamic value, and therefore the function is dynamic as well?
Which function did I apply?
The previous slide. There,
This
when
one.
you did let logger d equals config d.
Yeah, so I'm picking out the config d, and I'm creating this expression that listens to the event. And when the event triggers, I run the callback with a new value that I got from the event and recompute the value inside of my own cell. So in this cell, I got a logger. So whenever config d changes, I rerun this. And that's just a function as well. Map is just a function. It's a function that closes over whatever parameter it gets in, and then calls it when the config changes. And then you have some new value in your new cell. So you basically instantiate this one, dvar, for every new value you get. And you chain it back up to the root. It's a nice pattern that you might find useful. All right. Let's move on to the machines. Yeah. Audience. Yeah, all right. Mutually recursive function as a state machine. And now I'm like, yeah. So that's when you want to separate runtime states from each other. All right, let's have a look. Again, from Loggery. So in Loggery, we want to have multiple targets. They have different initialization, different failure modes, different ways of managing when, for example, you get too much logging going on, or they write too slowly, they consume from you too slowly, etc. So one way of managing that is to have a state for each of the cases that you might have. So we got loop here. Loop itself just declares, well, either you can say it's one function for all of this, or it declares init, running, checking, rotating, recovering as functions themselves. These corresponds to the lifestyle that you want your file logging to have. And you can see that it takes a file configuration at the very left. And that's, again, curring. Will is a way to recover when it crashes. And then some API. So also just above, you can see that it then returns a job of unit. So this is F#. That means that it's implicit what the function returns. But you can imagine, like if you were writing C#, you'd have to declare a job unit out here to the left, to the right. So that's something you can then execute asynchronously, or rather with green threads. But back to the state machine. So first of all, the function is declared, and at the very bottom, it's then called. And that kicks off the configuration, which returns a job. Maybe you can run things before you return the job, or maybe you want to run them inside of the asynchronous computation that you then hoist onto a scheduler and thread pool. But the running state here is one that I wanted to show you because it shows the transitions. What's a state machine but transitions between states, right? So in the running state, we might go and we might get a signal on the channel called shutdown. And then we simply want to shut down the state. Now, this is a bit mind-boggling because both the state I pass around the state machine and the state machine itself has states. But in this case, shutdown state means dispose of my connections. And then I'm just acting the return, let's call it promise that I get in, the ACK. And then I'm not doing anything else. So F# is indentation sensitive, and I don't have anything after API shutdown channel. So that's basically returning from my concurrent job. But in the rotate channel just below, you can see my to-do there, but I'm going to the rotating state. And that means that I don't listen to the shutdown command anymore. I don't listen to the logs and the requests and the metrics coming in here anymore. I only now want to do the rotation of files. And because I'm potentially getting thousands of messages per second, it's pretty nice to just say, I'm not going to pull that channel anymore. In this state, I'm only going to rotate the file. And by calling into the rotating state, even though all of this is a concurrent job, something that executes on green fibers, you don't actually have to have any synchronization primitives in there, because it's enough that you have one job, one green thread of execution, and you change its state. That's enough to synchronize with. And the rest is just signals coming on channels, like you can see at the top and further down. So similarly, once you've written, you want to check if you've gone overboard and written too much logs into the file, for example. And if something goes wrong, you have to crash, basically. So this is what the state machine could look like. Do you have any questions on this? All right, then I just wanted to give you some more resources that you can look at. I know Haskell.org isn't a good visual link, but if you click this link in the PDF I have online, you can go to github.com/HAF, and then you find this presentation there together with the sample code in TypeScript I showed you. And you can then also click these links inside of the PDF to find different patterns and different ways of writing. And like my writing style is not to use too many monads, monoids, etc. There's also a very nice blog entry by Alexis King, one of the committers on Hasura in India, called Parse Don't Validate, which is about the way that you do control flow when you want to validate. So instead of then just having your ordinary if this then that, you can actually build everything into a parser. So nice nuances there. And then of course you got some keywords you can search just for finding more interesting patterns in functional programming. So thank you for listening.
Yeah, I have a question. We haven't got any questions on the chat yet. If you have any questions, please ask them in the chat. I have one question. What would you say is the most useful? You showed some different patterns here. What is the most useful pattern to learn?
So these I think are very useful. All of these. The most useful. Well, currying.
Or the easiest to learn.
Oh, the easiest is probably currying. You pass one variable in, you get a function back, and that's it.
Yeah. And what's the most useful? What do you use every day? Like I'm coding every day. Now I'm using this.
Well, I'm using currying every day.
Yeah.
And I'm using reduce or fold every day. And I'm also using the async pattern every day. So I'd say those maybe. The hole in the middle is primarily when you're writing the software architecture for an application. Then you write that in one place, and you do maybe in React you do a higher order component which just attaches it into your rendering pipeline.
Yeah.
And then you don't write it anymore. So you can then not have everyone do that because it's harder.
Yes, we don't. We have a lot of claps, people sharing.
Okay.
Yeah.
Okay.
Yeah, I have one more question.
Yeah.
As we have some time over now. I mean, I guess you started a program. What did you start with? What language got you brought into programming? And how did you end up here in functional programming?
I started with BASIC.
Mm. Yeah, that's we have some people sharing here.
So I'm not sure that's representative of a functional programmer, but it's something to start with.
Yeah.
So I learned how to do goto and line numbers, and quickly realized that it's not scalable to write those line numbers all the time. I didn't even have an editor to write them for me. I had to type them out. But that was not for very long. But then I went into ASP, a VB script, and VB, and VB.NET, and C#, and then JavaScript, and F# and ActionScript, and a couple of more. So it's been a very crooked journey, but it ended up in a good place.
Cool. I started myself actually with BASIC, and then ended up in Erlang, and then leaving software programming. So maybe that's not a good good example.
That's a final state, Erlang. If you go there, you will become too bitter and must leave.
No, don't say that.
You know I only speak the truth.
Okay. Anyone else have any questions? No? No? Then thank you very much, Henrik.
Thank you.
For your speech. Yeah. Yeah, you want 5 minutes? Yeah. I'll just tell the people. Yeah, thank you. We'll just, let's see. The screen is rendering. It's using BASIC. That's why it takes time. Go to line 10, go to 20. You got a good question? Yeah. Go for it.
Can you turn me back on? Yay. Okay, so we got a question here. Care to discuss how to approach state machines with distributed processing? The state varies to be passed around or even persisted over time. Right. Yeah, that's a big question, and it's a fun one. So to start out, what's a state machine? Of course, it's something that takes a state and it takes an input and it returns a state. It's a Mealy machine. And in distributed processing, you have the problem that the processes, they fail. And when processes fail, you need to be able to recover. And then you have different primitives to do that. Then you have algorithms like view-stamped, view-stamped replication, or you have consensus protocols which are built on logs, write-ahead logs, vals. So the general pattern you do is that you take some input from the network, you deserialize it, then you have your state machine running, you give it to the state machine, you give it some ACK or NACK so that it can reject or accept the message so that you know on your networking layer when to send it out. It does its effect, and then it has some output state. And then it writes that to disk. And it also must write, like initially it writes to the write-ahead log, and then it updates its own database. And then it acts to the network. So you got 3 different moving pieces. And when it writes to the write-ahead log, then if It crashes, it resumes, it reads the write-ahead log, it applies everything on the 2 subsequent steps. If it crashes during writing to its own database and it completes, that's fine. Then it gets resent and you have to be idempotent. And if it writes to both, but it doesn't ACK, then again, idempotent, and if it does everything, you're fine. But that's just for one process. Now, if you want to replicate it, you also need the atomic broadcast primitive. And that means that you want to make sure that every process receives every message at least once, preferably in order, but you don't have to. So if you don't have order, you have to do sequencing. So you have to do a sequencer at the receiver. If you want to be linearizable, you need to have idempotence. And then when you get the message, you apply it like I just said, and then you broadcast back. And the ACK itself can either be batched or singular, but the point is that you need to have at least a quorum understand that the ACK has gone through. So then I recommend looking at Diego's work on Raft, and you can look at the different implementations, etc. D, you got Consul, has its own implementation, and so on. So they go through it really well in their presentations. There's also, I don't remember the name, but something called raftexplainedvisually.com, something like that, where you're basically stepping through the protocol to understand how everything works. So given that all of this works, the stuff I just described has the problem that you have asynchronous systems and they can drop messages. And that's why you need atomic broadcast. So that's something to look up as well. There's also Peter Ballis you can look up. He has a lot of good stuff written on state machines and distributed systems. And I think I'm going to stop there. So that's how you do it.
Thank you very much, Henrik.
Thank you.
Yes, and I will introduce the next speaker, if the screen will render. And then I realized I actually didn't stop in Erlang. I went programming in, first I went programming in Excel for a while, and then I leveled up to PowerPoint. And then I leveled out to Python, actually, because I realized I need to learn program again. So I learned to program Python for fun. Next speaker, C++ for Functional Programmers by Harald. I'm super thrilled that you're here, and that we will see some C++ programming doing functional. So give it up for Harald. Thank you very much. Voila.
Okay. So yes, this is an interesting setup. Thanks, Funel, for hosting this event, and thanks, Magnus, for inviting me. When I published the title of this talk on Twitter, I get actually a reply like this. And if you're a little bit in computer history, like I do, then you will find it as funny as I do, maybe. So now you know my sense of humor. So who am I? My name is Harald Achitz. I'm originally from Austria, but live now in Sweden. Developer programmer. I deliberately not used engineer because there is a talk C++ needs software engineers, not programmers. So, but I think engineering is just a small part of software development. It's more like gardening. Things grow wild on this side, you need to cut it in shape, and you need to apply a little bit dung on this side that things grow, and then bugs come and want to destroy everything. And the storm in form of a project manager who ruins the whole season, things like this. So yeah, if you want to know more about me, there is a link to some info. And there is also a link to the slides if you want to have them for later. But now to the talk, C++ for fun and functional programmers. So why do I think is it a good idea to talk about C++ for functional programmer? Well, first of all, I like to talk about C++ in general. So that's always good. But there is actually more than you would think for functional programmers. C++ is an interesting language. It has a lot of it creates a lot of emotion by many people, not always very rational. I think one of the reasons is it's not good accessible. People get in touch with C++ in school or university with total meaningless examples from teachers. They should teach maybe C++. And then they maybe also enter interesting projects, very hardware related, from hardware engineers. They're more in hardware than in programming. So I thought that I show a little bit that there are basically from the very beginning functional aspects or influence in C++, and that this is pretty interesting for functional programmer. So this is a tutorial. So in the description I said no C++ knowledge required. And so we will not go into very deep stuff, because first I need to create a common understanding or some common knowledge. And then when we have this talk, I can refer back, and maybe in the future we can go to more advanced stuff. But I think this will nevertheless be very interesting. But a little additional note, it will be an intro and tutorial in a nutshell. So I will go in light speed over things as I used to do. It's not that to explain you something that you go out or stop watching and you know everything, right? The point is you have heard and saw some things and see, oh, this is something that is beautiful, I can do it. It's interesting, and you have a first door open to enter the C++ world, basically. Yes, slide numbers, if you have questions, here on the top. And this is the program. So we'll go a little bit about the history of C++, language and the standard library, functional ideas and concepts in C++, and we'll look at some code, of course. And I will explain some of what I think are the most important things in C++. And then some literature tips at the very end. So the history of C++, I have this picture. I will not tell a lot. You can go to YouTube and Google for Björn Strostrup. There are talks 5 minutes to 2 hours, interviews about the topic. I've just took this picture because it shows Björn talking last year with the title C++ 20 at C++ at 40, which means C++ is 40-year-old, and which is quite old for a programming language. And C++ 20 is the latest standard which was approved. And it has this picture of the blind man and the elephant, which Björn uses very often in his presentations. So the blind man, depending on where he touched the elephant, creates a different picture in the head. And the elephant is C++, right? And the blind men are the people around. So what is C++? And I think this is a very good picture. So as said, C++ is very old. Notables, it is an ISO standard. So there is not one single company driving the whole thing. There is ISO consortium or ISO, yeah, don't know the actual name, but they have votes. There are national bodies, and each national body has a vote. And then there is a committee, and if you want to have changes in C++, you need to write a paper. Then you need people or you need to present it at the ISO meeting. And this is how the language evolves. So it is a little bit, you can say democratic. Of course, companies that can afford sending people to these meetings and have the national body have a little bit more influence, but it's not just one company, it's multiple companies. And the other thing what is worth to realize is since 2011, all 3 years is a new standard released. So there is a lot of progress in the language. It took very long to come to 2011, but then based on this experience, people said, okay, we will release all 3 years what is final. And if something is not final, it has to wait 3 years, which is sometimes a little bit sad. Sometimes you need also to wait 9 years, like with concept that just come recently. But that's how it is, and it turns out to be actually quite good. Yes, the future of C++ is also interesting. I've took this quote from a paper that Björn Strostrup has written. So C++ is too complex. We need to make it smaller, simpler, and cleaner. And yes, it is too complex. We need to make it smaller, simpler, and cleaner. And please add these 2 new features, because we love new language features and things, right? And whatever you do, don't break my code. Because C++ is the backward compatibility you have in C++ is nothing you have in other languages that much, right? So if you have 20-year-old code that is standard compliant, it will compile with today's compiler, and you can reuse the code, which is industry loves this. Let's put it like this. And C++ is when you let's separate into two things. That we have the C++ language, and we have the standard library. C++ is the language is standalone. It's the compiler to compile your code. And then there is the standard library. You don't have to use the standard library. You can. I encourage people to use because I think it's a good library, but in some scenarios, people don't just use the language. And C++, the language is, I mean, the C++ people know that there is no perfect language and that C++ has a lot of problems. We know this and we have to deal with this. But there's also C++ is not do one thing in one way. There are multiple ways to solve a problem, and all these ways should be supported. This is why we say C++ is a multi-paradigm programming language, or a multi-purpose programming language. So it's basically where you have imperative programming, meets object-oriented programming, meets generic programming, and meets functional programming, bracket styles. Yeah, but this all comes together. And it's huge. So C++ is huge. So where to start? And I like this quote also from Bjarne Stroustrup. So within C++, there's a much smaller and clearer language struggling to get out, because this is as it is. This basically means if you come with people that come from Java, they will write very object-oriented. And if we have hardware engineers that come from C, you will have C with classes. And for the functional programming language people, you might also find your subset of the language that you can say, oh, this is the subset I want to use to get things done. Now let's come to the standard library. Commonly named STL, Standard Template Library, or it's HP Software Technology Lab. I'm not sure which one is actually. The intro was 1995. The work started 1 year earlier from Alexander Stepanov and Mrs. Ming Li. Alexander Stepanov was 1 year earlier at HP. That's why it might be HP Software Technology Lab. 1995, they released the first paper about the STL, Standard Template Library. And the central figure is, of course, Alexander Stepanov. There is this very funny quote from him. There is an interesting story. I will not tell this story because I will ruin it, but you can research it. But he's a quite interesting person. He's from Russia. He studied mathematics, had then to leave, went to the US and became a programmer. I was programming already previously. And the real story of the STL is it's the result of 15 years research in generic programming on different places with different peoples and in different programming languages. Actually, there was a book earlier already, Generic Programming with Ada, and Alexander Stepanov worked also a lot with Scheme and other program Lisp-like languages. So this quote is from the Byte magazine, also 1995. And the original STL, this was from the very first paper, this was the point it focused on. So it was algorithm, container, iterator, function objects. So you might already feel somehow home now, and adapters. When it became a standard library, then additional things have been added because this needs to be in a standard to be acknowledged and other things. So IO stream and utilities and memory allocation and some other things. And today it's even more stuff. You have threading, you have file system library, type trips with new vocabulary types, ranges, plus, and people want to have networking there, everything, right? So they say where to start. It's huge, and I say start with STD algorithm because this is you will see the beauty there. So now let's come to some motivating examples. I've taken some examples that for functional programming people should know and could relate to. It's filter, map, and reduce or fold. So this is filter in C++. We have here a vector. I think if you need a data structure that holds a list of things, it's use a vector in C++, and we take integer. We have some values. Here we have a lambda function that returns if something is odd or not. Here we have something to store the output. And here we have the algorithm. It's called copy if. It takes the input iterator to the begin. It takes an iterator to the end. So it is a range, a half-open range. It goes from the begin to one before end. We have here an adapter that inserts stuff into the result. So we don't need boilerplate. And here we throw in the function object. And filter is called copy if. And it's not a function that returns a new list of something, because you could have in the output anything that fulfills the concept of a container. And yes, this is, and if you would have to have it as a function that you say, I put in a container that returns a container filtered on a function, Alexander Stepanov said, I write algorithm, not wrappers. So you would have to implement it itself, and it's actually a nice exercise to start playing around with these things. So now let's look at the map function, as it's commonly used in functional programming under the name map. We have a data structure called map, so it is called actually transform in C++. We have again a array of data. I have a scale factor. Now the output has a different type, because I cannot have integer types anymore. We have again the transform function that takes the range, the data range, as the input. It puts the result here. And here I have, I write the lambda on the fly that even captures something from the environment. So you can have stateless lambdas, or you can have lambdas more like closures. It's up to you. It gives you the full power, right? This is one of the topics in C++. Oh my God, I have so much power. What to do with all the stuff, right? So, but I think it's very nice and easy. And you see the naming is again different. So you will find things under a different name, right? And this is very often, if you go to a different technology, people, you hear them talking and using words, and oh my God, what is this all? And then it turns out, oh, I know this, right? So you will have the same experience if you come to C++. Now let's look at reduce. So again, I take some data, and here we have two functions, accumulate and reduce. So reduce is much newer. The difference is with accumulate, it takes the input range, it takes the initial value, applies the operation. In this time I took the plus operation, but you can do any operation, multiply, whatever. Takes the first element, applies the operation with the initial element, takes the result with the second, takes the result with the third, in order. Reduce does not care about order. This is very useful if you want to parallel stuff, because this reduces basically a nice function to run in parallel. But some people depend on order, so we have these two versions. And there is also something that puts these things together, transform and reduce. So here I have a string array with strings. I want to know how many characters are there. So I have this function transform reduce. Here you say please run in parallel. So you don't need to go to the low-level stuff, right? It will make the optimal thing for you. It will be very hard for you to write this better by hand. We take again the input range. We have the reduce part with the initial value and the operation. And here we have the lambda for the transform function, which returns the length of the string, or the character count of the string. And then we get back the character count of this, executed in parallel. So I think these have been some motivating examples, and please observe, we saw a lot of dynamic memory management. We saw no pointers. We saw no new and delete, and there have been no raw loops. And this is how C++ can look for you if you take the subset from C++. And now you should all go to the computer and write C++, right? now you love it. So, but let's look a little bit more. I've taken some functional concepts that are known from functional programming language, and let's see if they relate to C++ and how they do this. Higher order functions, immutability, recursion, functional purity, and referential transparency, which I will do in once. So let's look first at the higher order functions. And yes, C++ has higher order functions. I mean, you have already seen we have thrown function objects around. But let me show you this nice code. It's from a library called Lift. You might already develop an idea what this is doing from the name. We have here a function that takes 3 functions. It's called if then else. The first parameter is a predicate, returns true or fails. The second is what happens in the good part. And the third parameter is the function that happens in the bad part. So this function, what it does, let's remove all negative values to 0. So here we have the if it's less than 0, then return a 0. Otherwise, return the value. So you get an input list of numbers, and we use what we have seen already before. We have some output container, and we put in our range. We use the already known transform function and apply as the working host the new function negatives to 0. So yes, and if you look at these links I have here, there are 2 talks from Björn Faller is the name of the author of this library. There are 2 talks. One is 30 minutes, one is 1 hour, just about higher order functions in C++. So you can look at this if you want. It's very nice. So now let's look at immutability, because this is what people want also, an immutable data structure. And C++ has const, and this is not exactly the same. But I need to explain now some C++ essential, why I don't think this is a big point. So first, value semantic. An assignment creates a copy. I have here a vector, or I could have any object of any complex type. And if I make here an assignment, a copy happens. So I don't share data. If I change now B, A stays unchanged. Right? Other languages, if you make this, depending on the underlying type, if it's bigger than the pointer size, then you will have a reference. You have shared data. C++ copies stuff. This is very essential. Also with function arguments. If I specify a function argument like this, then the function gets a copy of the input data. So the function has its own version of data. And my data I have here before calling the function says unchanged, because this is copied. This is very nice if you start a thread function, right? Give it a copy of your data. In other languages, you need to do something extra to make clonable or something like this. So references, there exist references in C++, but they are explicit. You need to tell this is a reference, and they are actually an extra type also. So here I create a reference. This is the syntax for creating a reference. And now I have shared data with all the problems. So you need to tell something that is a reference. And everything is mutable until it's declared const. So what a lot of C++ developers say these days, including me, we have the wrong default. So yeah, but this is like it is. You need to write a little bit more to have the right code in C++. And this is what often is left away. But you need to write const, and then you have an immutable number. And then you can use a reference as input. And then this function cannot change the data it gets to work with. So the compiler will reject to compile this code. So you can have const correctness. You just need to be a little bit more verbose. And so we have immutable data if you want. You can create apps.
Sorry, we have one question. One question on the chat. So in C++, the anonymous lambda expression is starting by bracket, right?
It's static by brackets, which is the capture clause. So in the bracket, you put in what comes from the environment. I go back maybe here. So this one is the capture clause. And if we say, let me go even more. Okay. So here is the capture clause. So here is what it takes from the environment. Here it takes the scale value from the environment. Then you have the function arguments. And then you have the implementation. So it's good to go over the essentials again. So value semantic references are explicit. Everything is mutable until you declare it constant. And you can totally create functional data types. There is IMMA, it's a library. So this is a link. If you have the presentation, you can click on it. There are talks about it, postmodern data structures in C++. It's a vector where you add an element, you get a new vector. So serializable, immutable data. And I have made a 7-minute talk, const should be a type, which actually said const should be a type. And you can look at it. So let's have a look at recursion. So yes, you can do recursion in C++, perfectly fine. Look at this quicksort implementation. If you would have this in school, you might be already a C++ developer. But I mean, the details are now not relevant. Let's just a few notes here. We are const correct. So this is good code because it cares about detail. This helps also the compiler a lot to reorder code, because compilers write code today not like you write it. They do what they think is the fastest for the architecture. The working horses in this function comes from the standard template library here, especially partition. And here at the end, we have the recursive calls. But you need to observe one thing. Tail call optimization is not part of any standard. There are compilers that implement it, but there is no guarantee, right? The compilers tell you, okay, usually it's so if the last call is a function call, the tail call can be optimized. We were talking about getting rid of the stack values, right? So functional programming languages, they are very good in this because they have no other chance. That's the only thing they can do, and they have a garbage collector. In C++, you might have other things on the stack, so it's a little bit more complex. But usually in this function, I have here two recursive calls at the very end. I cannot tell you if the compiler will tail call optimize them or not. It will in any way tail call optimize this one. I can say, yes, this will be. And the other one, you need to have so insane amount, huge input that it doesn't matter, right? But observe this. So in C++, we have loops. They are there for a reason. They are faster. But we have algorithms. As you have seen before, you don't need to have to use loops that extensive. You can make loops via algorithms as expressions. So let's look at Poor-end functions and referential transparency, because this is also something functional programmers like. And yes, yeah, here. And let me take these concepts are not exclusive to functional world, right? Even C, some compilers allow you to put attributes on function to tell the compiler this is a const function, so referential transparency function, or a poor function. So for KCC, you can do it like this. Why? Because the compiler can optimize code, right? So if you're in C++, everything you want to have is the most performance. Or this is why you use it. So here we have a function where you can replace the input with the result, and if the compiler knows the input, it can put the result there. Doesn't need to calculate this. There is of course no runtime in C++, but that does this for you. You can implement it. It's a nice exercise. Here we have a function that is just poor. It takes a pointer. It has no side effect. It creates a hash value out of the input. But what comes in, it can change. So on the address of the pointer can be hello, and the next time it can be world. So you cannot, it changes. Of course, this is what I show you here. This is C, and it's up to the developer to guarantee that there are no side effects. So in C, people trust developers. C++, people trust the compiler. So C++ has const expression. So declaring the same function's const expression, the compiler cares that everything is okay, that a function has actually no side effects and doesn't read global state, whatever. And even if you put in a pointer here, so this function is actually useless because you have to know the pointer at compile time. You can have static strings in your binary, this is not a problem, but you cannot change this. And the compiler will not allow to give one time the same address with different values. So const expression is wonderful. Again, you have to explicit add const expression keyword to functions to do the right things, right? Constant expression. But if you add this stuff, you're already pretty much in safe land. So you find all these things in C++. And if you get used to it a little bit, how to use it, you will like it. Now, what about pointers, right? I mean, I'm standing here talking about C++ and no pointers. This is not true. I had one pointer, right? But let's go with pointers in Lightspeed. Pointer is like a maybe type. This is the simple thing. It can point to something or not, which is actually very nice. I mean, C++ has a vocabulary type for this. It's called optional. But a pointer still, if I give a function and I have a pointer as an input, I know, okay, I get a resource. I don't own it. I can use it. And I can check if there is something or not. It's very nice. I know this. The other thing is pointer is just a resource. It's a memory resource. But you can also have resources like file handlers, open sockets. And you can crash every program if you have too many file handlers. So there is nothing magic about this. But let's look why I don't care about pointers in reality. So let's look at the maybe stuff, right? This is the thing, a function. If I have a function signature like this, it tells me, okay, there is a pointer. I'm not the owner of this memory. I can read it. That's all, right? I get even const data, so that's nice. So this is the simple thing. Now the resource pointer, why do we have this actually? So we want to transfer ownership. We want to create something that if I want to transfer something to a caller, I either have to copy it, if I have it on the stack as a function, or I create it on the heap and then transfer it then to the caller. Or I have data that doesn't fit on the stack because it's dynamically resizable or it's simply too huge. Or something like is this a resource by definition. I mentioned already file descriptors and so on. So how do we deal with things like this in C++? So resource management in C++ works like this. Scope is king. Scope is here starts the scope with the bracket. Here starts another scope. Here ends a scope. This scope ends here. I declare here as a variable. It is created here. And when the scope ends, the variable is destroyed. And here I can create a scope just for, because I think I use it here. And create another variable. And when the scope is ended, this instance of paths is destroyed. And when we exit the function, this one is destroyed. So this is very essential to realize. This is basically the C++ garbage collector. When something is created, you have a function on it. It's called a constructor. If something is destroyed, it's a destructor. So this code I can read by seeing, okay, F has a destructor. It will be called here. It's not a garbage collector that will be called somewhere. I don't know, now or 5 minutes, right? So I can reason about the code, what's happening. And this is where objects come in handy. So this is the cool usage for objects in C++. So resource creation, constructor, resource destruction, destructor. And your object or your type might look like this. You have some class. You have a private section with the resources you want to protect or manage. You have a constructor function, builder function, that can take argument and create the stuff. And here's the destructor that cares about that the resources are freed. And this is, of course, now maybe a little bit a lot. You need to work with this. But there is a pattern for this. It's called resource acquisition is initialization. We don't have good marketing terms in C++, but this is like it is. So basically, you bind the lifetime of a resource, can be memory, can be sockets, whatever, to the lifetime of an object. And for object on the stack, the closing bracket is the garbage collector. So there is no black magic about memory handling. And we have helper classes today to work with pointers. There is something in the standard library, unit pointer. A unit pointer is a pointer resource. It can just have one owner. So if you want to share this with another, you cannot share it. You have to move it on to another instance. So the ownership of the resource is clear. And you know when this resource goes out of scope, this pointer will go out of scope. Then there is a shared pointer. There are some interfaces which, yeah, force you to do this. Usually, I have a real interface. We write code to interface Java and Objective-C and Swift. And since we need to pass in stuff and we don't know when this will be destroyed, everything is wrapped in shared pointers. But usually the unique pointer, like a steady vector, is your default list class. Unique pointer, if you really have to deal with pointer. And how you use it is actually like this. For example, this is just a slide code, of course, right? But we have here a builder function that takes constructor argument. It returns a unique pointer of whatever it is, data, your resource. You have a function, make a unique resource, and put in the constructor arguments. So here the thing is created. Here we move the ownership of the unique pointer to the caller. So I have nothing to do with it anymore. Here in where I use this, I actually acquire this resource, and I call doJob2. And when we go out here, this object is destroyed, and in its destructor, the resources will be freed. But not just this. If this function would throw an exception, we would also go out of scope, and the resources are freed. So you don't have to worry about memory leaks. Actually, if you write today's clean C++, this is not a huge issue. You just need to learn the concepts, like you learn concepts from functional language with like this, and live with them. So summary of pointer, there are nothing to fear. I mean, of course, you find old code and old interfaces and libraries, and you interface C stuff and so on. But basically, think of this as just a resource. It's nothing to fear. So we have templates also. I didn't go into the templates a lot. This might be for advanced section. We have seen templates, right? So we have seen use a vector, which is a dynamic resizable array with integer or whatever type. So we have seen the unique pointer for a type, and we have seen a function that specifies also a type in this the return value. So basically what templates are, it's compile-time programming. You have a code, and everything that fulfills a certain concept can be plugged in, and then you generate the code, and it's type safe. It's checked by the compiler. It's not like a macro. It's totally safe code. So this is actually good, and it's a advanced step topic, but something functional programmer will also feel at home. But as I said, I didn't want to put too much content in this. So what we have also ranges since C++ 20. We talked about algorithm, and now I show a ranges example. It's very new from C++ 20. So algorithm can look with modern C++ like this. It is very nice composable and lazy evaluation and things maybe here. So we have again a vector with input data. I have an even and a square function. I have a for each loop, but it is a function. I put in the stuff, pipe this into the filter, then I drop the first element and then transform its map in your language. And here is actually the last function. This time I have a side effect because I write out to the console, but sometimes you need to do useful things. So ranges with C++ 20, nice thing, but they are on top of algorithms. So they still have algorithms under the hood, so to say. And it's good to know about algorithms when you learn about ranges. So now how to continue? If you are now, because I'll see, wow, I want to write C++, but I need to do something, right? How can I continue, right? So books, of course, books are always great. So this book is 250 pages, maybe. It's from Bjørn Strostrup, the creator of C++, and it gives you a safe subset of C++ that you can use without headache. And I said it's just 250 pages. And you have a lot of tools in your hands to solve daily problems. So you don't need to go, and I need the standard, which humans can't understand, and then 5 other books with 1,200 pages. No, start with this book, right? Seriously.
How much of the language is covered in this?
Very lot. A lot. I mean, the whole language is covered in the standard, and it's, I think, at the moment between 1200 and 1600 pages. But this is nothing you are interested in. This is for compiler writers, yes? So don't get you confused from this. What you want is this. And this gives you everything you go to start with. And the rest will come by time, and you will find more bad information than good information. So stay with this, right? So I have 2 more books because I think functional programmers should be interested in mathematics. They are from Alexander Stepanov, both co-authored with another person. The one thing is from mathematics to generic programming is basically a history of mathematics. So it starts 2000 BC with fast multiplication, continues then about not invention, but mathematics detected over time, and how this influenced algorithms. And it uses the greatest common denominator algorithm, then how this influence of the mathematics influence generic programming, and at the end you come to generic programming that works with any type that fulfill a certain concept. And it has a lot of details about the history of mathematics, and also a lot of very mathematical exercises for you. I jumped over the most, I have to say, but some people will like it. And the other one, Elements of Programming, is basically the mathematic foundation of the standard library, the original standard library. So this is basically a mathematic book about programming. If you like this stuff, you will love it. A lot of people love it. It was for me a very hard read and very hard to understand, but I will maybe read it a second and a third time in my life, right? And then I have one more book. This is Functional Programming in C++ from Ivan Kut. I don't want to say the name wrong, but I mean, you have a link there. And there are more books actually, but I have read these 4 books, so I really can recommend this. And there you find also the details how to implement the monad in C++.
Yeah, and Ivan is also in one of these podcasts.
Yeah,
I
Functional
think,
Geekery.
exactly,
Yes.
and I think Oscar posted in the meetup comment. You can find the link to the pod there.
Exactly, yes. So he's very well known for being a functional advocate in C++. And there you find assessed programming patterns, in more deep. But first start with Strostrup, because then it's easier to read this book. So, and then you need some IDE. So a lot of people struggle getting started. Where shall I put my code in, right? Because this was a long time a painful topic. So Visual Studio, if you're on Microsoft Visual Studios today, actually pretty good. I have to say something very good about Microsoft C++. They're very good today. C++ 19 is also free available if you want to have a lightweight editor, Visual Studio Code, but then you need to write your own CMake files or something. If you're an Apple, Xcode, if you know to Xcode by using another editor. Just one note, Apple Clang is a own compiler branch. You don't know when they put things in the standard there or not. So if you go to Xcode and want to write C++ 20, you might find that Apple hasn't implemented them yet, and you might want to wait 1, 2, 3 years. No one knows, right? Because it's Apple. For other, JetBrains CLion is also an IDE. So JetBrains, if you know, they write the Android Studio, and there is also some Java IDE and PyCharm and whatnot. So this is a very good IDE. It's free for open source and educational. So, and if you come to a C++ meetup, you can win JetBrains licenses also. So to plug the user group. And then there are also online compilers these days where you can put some C++ code into a text field, and the compiler, you say compile and run, and you can play around with this. There are much more than these 3. I have just taken these 3 as an example. The one Godbolt actually shows, because also run the code, but it shows you the disassembly, because some people want to see, if I write the code like this, I get disassembly. If I write it like this, it's disassembly. You don't want to have to do something with these people because they're strange. But you can also put in their code and execute it and test different compilers in this IDE with Clang, with GCC, with Visual Studio, and so on. Yes, and as I said, there are much more, so it's easy to go starting. Yes, and then you need to write some code, of course. I mean, you can read as many books and watch as many tutorials and listen talks and whatnot for years. If you don't write code, nothing will happen. And it is a little bit painful at the beginning, always when you start something new. Feel a little bit, oh my God, why? But yeah, it happens to me with every language. I pick at the beginning, I feel not very well, and then I pick it up and I feel better after some time. And if you start with C++, with the subset from in Björn's book, you will feel good after some time. And this is actually my lightning speed talk. Thanks for listening. And now we have time for questions, and I have 84 slides.
Thank you. Thank you very much, Harald. We don't have any questions, but we have people saying, I'm enjoying it so much. Such a great presentation.
Oh, thanks. Yeah.
Yes. So we'll give you an applaud here.
Oh, thanks. Yeah.
Let's see if there drops in any questions. Otherwise, I'll summarize. Yeah. Thank you very much, Harald.
Yeah, enjoyed it.
Yes. So now there's like no excuse for C++ programmers to continue to work as you are. You should go functional. It's very easy. Yes, if you don't know how to do it, just call Harald and he will help you. Of course. Joking. Yes, that was it for this time. Before we started, Henrik had this idea, the guy that started to speak, that we should have like a panel and we should have different people coming from different languages and discussing different fun topics. I think that would be a blast. We could get Haskell people, Erlang people, C people, maybe assembler people. No, but we'll get some people on a panel, and we'll have some, I don't know, prepared questions and a talk. That would be fun.
One problem, and then you would say for each language, how would you solve it in your language?
Sounds really cool. I think that would also show like the pros and cons of different languages and ups and downs, because there are pros and cons. I have myself written all sorts of languages, and there are pros and cons of all languages. Yeah. Thanks, Henrik, for a great idea. We'll look into that. I think that would be fun and also be very, I don't know, people would learn quite a lot. Yeah, if there's no more questions, then we'll end the live stream for today. And thank you everyone for viewing and watching. And remember to join the MeetUp group, follow the YouTube channel. We'll post the streaming, or we cut it down into two different sessions and post it on the YouTube channel also, if you want to watch afterwards. Yeah. Thank you very much, and bye-bye.